Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster series, and in this video we are going to refactor our whole player code so that our player is also kind of like a thing. So we have implemented the thing class in the last video, and now we are going to make it so that we can reuse that class for anything in our engine, including the player. So for that we are going to first of all look at thing.h. Now in here there are a lot of changes. First of all, we have got this forward declaration of map, because we can't include map.h, it would be a recursive include. Anyways, this thing function now has got a thing class has got another property, which is the angle, and it takes a constructor which takes the angle as an argument. And we have also got a function called move. Now this is the general function that will be used to move anything in the game. For example, if enemies want to move, or other obstacles, or other like projectiles want to move, or the player wants to move, everything will use this function, and this function will be the one in which we implement our collision detection and resolution and stuff. And we have got a private function which is the check map collision. This is basically the same function from the player's version, so we essentially remove those things from the player to this class. So we have also got a thing.cpp now, because well, there are implementations of that. And in here, first of all, we have got the move function. If the move vector is 0, then we just return, because we don't need to do the other calculations. If it's 0, that would just be a waste of time. And then we calculate the x and the y offset, and do the map collision just like we did in the player. And this function is basically identical, with one small difference, which is that we make sure that the thing is not equal to this. So the player is also going to be a thing, and everything else is also going to be a thing. So we want to make sure that we don't accidentally get a collision against ourselves. So if the thing is equal to this pointer, then we are going to continue. And similarly, we have to actually do this in the y as well. So we are going to say our thing equals this. So yeah, that's pretty cool. And now we can go ahead and open up some other stuff. So let's go ahead and first of all take a look at player.h, because now inside of player.h we don't have any of the position or other attributes. What we do have is a thing pointer called thing here, which well actually represents the thing. And then we have got the player, and then we have got the update function. So if I open up player.cpp, what you should see is that the player now has got a constructor which takes the thing argument, initializes the thing with it, and we have got the update function which only which updates the thing's angle here when we are turning. And for the other thing, what it does is that it calculates the move vector, and then it uses thing move with the move vector multiplied by the speed multiplied by delta time. So the player doesn't do the movement on its own. For the player, we just pass that, we just call the function in the thing class. So this is much better. And another thing we have changed is, if I open up render.h, we have now got it so that, by the way, you might also notice we have removed the draw function from the player, because it will be drawn automatically since it's just a thing now. And in render.h we can see that the draw 3D view function does not take a player or a reference to player anymore. It just takes a general pointer and a position and an angle. And in render there were a couple of bugs in the renderer which I have fixed. We don't need to include player.h, by the way. And those bugs were that mainly, well, you can see that we actually use just the angle here, not player angle, whenever we are doing this. Anyway, one of the most important bug was that the sky wasn't exactly correct, so the Euler formula was kind of broken. So a much simpler way to do this is to just take the angle of the player, divide that by 360, which means a full circle, and then multiply it by the size of the sky texture, and that will actually work correctly. So yeah, we have got that. And another thing that we are going to do is that we are going to go down here. And by the way, all of the other changes are just the player, and instead of using player we just use the position now directly. And by the way, we have got another change. If the thing's texture is less than 0, then we just continue, don't draw the thing. That's because we want to allow things to have texture set to -1 if they are not drawable. So for example, the player is not supposed to be drawn, the player thing is not supposed to be drawn, so we set its texture to -1 so that it can be skipped. And one more thing is that we were actually having our walls being mirrored because we did not invert the texture coordinates depending on the size. So we have got our texture coordinate, and by the way, just make this an int, and making it a float kind of results in some errors. and then we check if our hit was not vertical and our ray direction of x was greater than 0, then that means that we were looking at a different direction, and we need to kind of mirror the texture to make sure that it displays the correct direction on every side, and we do the opposite for the y as well. So yeah, that's pretty much it, and now let's go ahead and see how this all ties together in main.cpp. So in here, the most important thing you can see is that we get our we first of all define all of our things, and the first thing is the player. So it's at 2.2 by 2.2 at the grid position, and it has a size of 0.4, and it's set to, the texture is set to -1, and the angle is set to 45 degrees, and we've got the other things just like we had earlier. Then we have got our renderer, and we initialize our player with the first thing, and we must do this before we do any other thing, because if the thing is not initialized correctly, then this will be actually rearranged, so it might get problematic. So we just need to make sure we set the pointer correctly for the player in the beginning, and then we loop over the things here. We do the same thing like setting up the block map like we were doing earlier, and in here we have actually got a bunch of different changes. So when we are drawing our 2D view, what we make sure is that we have got our view the set center. We just use player thing position, and another thing is that we now have got a rectangle and a line as well. For the rectangle we set the fill color and the outline thickness, and when we are going over each thing we are going to display its angle as well. So if we set the line size to thing size multiplied by the grid size multiplied by 1.25, we were basically, this is kind of a simplified, not exactly simplified, kind of a more generalized version of the draw code in the player. We set the line's rotation, we set the rectangle size, and we create a variable called color, which is by default green. However, for the player, if it's the thing is equal to the player's thing, then for the player we change the color to yellow, and then we set the rectangle outline color and the line fill color, and then in the end we just draw it. And yeah, that's pretty much it. And for the 3D view we just use player thing position and player thing angle, and that is going to work correctly. So if I go and run make, what you should see is that while there isn't really any difference in the 3D view, we still get everything pretty much like we used to get. We can still collide and it still works perfectly. And if I go under tab, you can see that the player is now drawn, everything is now drawn with angles, and the player is drawn in yellow, and the player does have the correct size. So yeah, that's pretty awesome. And what this means is that we have got essentially all of our abstraction layer working correctly. So our player is now linked to a thing correctly, and now we're gonna just implement general stuff for the thing, and we won't need to do any special purpose stuff for the player. And yeah, that's pretty much it. And I'll see you in the next video, in which we are going to perhaps implement a game class and kind of encapsulate our game code in there, because now that we want to add some actual game elements to this, we are going to have to distinguish between when we are just walking around the scene empty, like without running the game, and when we are actually running the game. So we'll do that in the next video. Make sure to like and subscribe, and stay tuned for that, so you don't miss the next one, and share this video with other people as well. And bye.